So we've been asked by Han Solo to determine what the net force on the Millennium Falcon is by the thrusters when it makes the jump to near light speed. He's told us that the mass of the Falcon is 30,980,030 kilograms. Our other givens are the initial velocity of 57, 34, and 76 meters per second, and the final velocity of 169357479.1, 101.020250.6, and 225809972.3 meters per second. Han has also told us that the time it takes to make the jump to light speed is always 2.5 seconds. To solve Han's problem, we'll be using the momentum principle and the equation for momentum at near speed of light velocities. Substituting those two equations, we get one equation. This is the mass of the Falcon times the final velocity of the Falcon divided by the square root of 1 minus the magnitude of the final velocity over c squared minus the mass of the Falcon times the initial velocity of the Falcon over the square root of 1 minus the magnitude of the velocity of the initial velocity of the Falcon divided by c squared. All of this equals the net force times delta t. Now that we have our equation set up, it's just a simple matter of plugging in all our givens into our equation and solving. So we plug in the mass of the Falcon, the final velocity, the initial velocity, and the time it takes to make the jump to light speed, multiplying those together. Then we can plug in the magnitude of the final velocity, which happens to be 8 meters per second below the speed of light, the magnitude of the initial velocity, and c, the speed of light. Solving the denominators, we notice that the denominator for the initial velocity is approximately 1, but the denominator for the final velocity, which is close to the speed of light, is not 1. This causes the final momentum to be much higher than what it would be if it was at an otherwise lower speed. Finally, we get vectors for the initial and final momentum. These are 2.2790 times 10 to the 19th, 1.3594 times 10 to the 19th, and 3.0387 times 10 to the 19th kilogram meters per second for the final momentum, and approximately 1.77 billion, 1.05 billion, and 2.36 billion kilogram meters per second for the initial momentum. This is all still equal to the net force times 2.5 seconds. Now we can subtract the initial momentum from the final momentum, but because the initial momentum and the final momentum are such vastly different numbers, it really makes no difference to the final momentum. Now all we have left to do is divide our change of momentum by our time interval, which is 2.5 seconds. Doing this, we get a net force of 9.1161 times 10 to the 18th in the x direction, 5.4376 times 10 to the 18th in the y direction, and 1.2155 times 10 to the 19th in the z direction newtons. Now we can go tell Han Solo that making the jump to light speed really does require a lot of force.